Here's your text with punctuation added. The hypothesis of ancient grandiose explosion is, for the most part, recognized by most specialists as the fundamental explanation for the beginnings of the universe, encompassing the creation of stars, planets, and all life, including us. Not enduring its reasonably flighty name, the term enormous detonation properly captures the massiveness of the event. At first, the universe was a thick grouping of particles squeezed into a space more modest than a pinhead. From this moment point, a gigantic impact of issue happened, known as the huge explosion. This compactly summarizes the association that unfurled over billions of years. Anyway, no matter what the enduring distinction of the hypothesis of how things came to be, movements in logical information have dynamically tested its expectations. When NASA shipped off the James Webb Space Telescope, the biggest and most high-level space observatory to date, researchers estimated that its perceptions would support the hypothesis of ancient inestimable explosion. Tragically, after only 1 year in space, the telescope has astounded specialists with its groundbreaking capacities, giving exceptional looks into the universe's past. The James Webb Telescope's divulgences have uncovered frameworks so old that they could reshape how we decipher the universe's beginnings. This unforeseen divulgence has started serious interest among analysts and fans alike. One such essential divulgence came when stargazer Rohan Natu, examining early pictures from the James Webb Telescope, inadvertently tracked down a framework that amazed everybody. This universe, named Glass Z13, appeared to be strangely huge and followed as far back as a brief time frame after the huge explosion, making it more seasoned than any recently seen world. Nat's energy was unmistakable as he bestowed the disclosure to partners in the world, portraying it as past anything space experts might at any point envision. The James Webb Telescope, situated a long way from regular impedance and outfitted with cutting-edge INOV, was planned to plunge into the universe's earliest age, known as Grandio Dawn. This period, shrouded in secret, signifies the arrangement of the universe's most noteworthy stars and universes. By inspecting frameworks from this period, analysts desire to refine how they decipher major astronomical cycles, like the effect of issue and dim energy. Initial suspicions for the James Webb Telescope's disclosures were modest, anticipating a long time away from universes. Anyway, the truth outperformed all projections. The telescope's photos uncovered frameworks of astonishing turn of events, testing existing models and inciting a tornado of assessment. As scientists continue to analyze the James Webb Telescope's information, the implications of these disclosures could be huge, presenting a new period of cosmological cognizance. The astounding divulgences from this vital observatory offer an enticing investigate the universe's previous, driving humankind's excursion to unwind the mysteries of presence. As early frameworks emerged, researchers and observers wound up in a scramble to get a handle on them. Could this gathering of strangely tremendous and splendid early universes at any point be whimsical, maybe because of blemishes in the assessment of the telescope's underlying insights? Or, on the other hand, if real, could they somehow be obliged with standard cosmological models? Conceivably, were they the primary implies that the universe is more unusual and more mind-boggling than our boldest hypotheses had expected? The question is not as much as how we could decipher how the exact universe we know emerged out of beginning phase disarray. The early divulgences from the James Webb Space Telescope might conceivably reconsider the underlying pieces of Grandio history. These segments worry distant ages in far-off frameworks, as well as our own presence here in the regular smooth way. As Imprint McCarran, a senior advocate for science and examination at the European Space Office, involved with JWST, remarked, "You fabricate these machines not to avow the perspective but to break it. You simply don't have the haziest thought how it will break." JWST's impression of early universes has been billions of years genuinely taking shape. Regardless, more unpretentiously, they trace back to the Space Telescope Science establishment in 1985. Around then, the Hubble Space Telescope was at this point a long time from farewell. Anyway, ever the foundation ments then boss Ricardo Jan mentioned that his gathering started pondering what could come after Hubble much further away. Paying little heed to beginning quarrels over focusing in on Hubble, Jan was steady, foreseeing the broad turn of events. Process fellow Waite, then deputy regulator of SD Sky, alongside a little gathering, began drafting considerations for what in the end transformed into the Bleeding Edge Space Telescope, later renamed JWST. They seen that while Hubble would be notable, its abilities would be confined by its discernments in recognizable light. The NGST, on the other hand, would find in the infrared reach, allowing it to enter further into the universe. The requirement for JWST became significantly clearer in December 1995, at the point when cosmologists coordinated the Hubble profound field discernment. Disregarding suspicions for tracking down 2 or 3 faint inestimable frameworks, the resulting picture revealed an immense number of universes stretching out back more than 12 billion years into the universe's arrangement of encounters. After more than 20 years of progress and at a cost of around $1 billion, JWST was finally shipped off on Christmas Day 2021. The telescope went through intensive testing, preceding showing up at its significant space objective a month sometime later. By July 2022, it was ready to start its long-awaited first year of science insights, known as Cycle 1. Some piece of JWST's starting mission was given to high-effect programs, including the Galactic Advancement Early Delivery Science Review and the GRIS Point of Convergence Enhanced Outline from Space, both highlighted uncovering understanding into the privileged insights of the early universe. As stargazers straightforwardly gave vast hours to examining discrete patches of the sky, searching for right-on-time universe grandiose frameworks, they from the beginning expected unobtrusive revelations, like a more itemized variation of the Hubble profound field. Regardless, they were in for a shock. Stephen Balance Lynn from the School of Texas at Austin, leading the SE project, appears to be legit that exceptionally distant frameworks should emerge exclusively after various data cycles from various activities. Anyway, to cosmologists' wonder, these universes appeared rapidly. Beforehand, the record for the most far-away known framework had a spot with GNZ 11, seen in 2015 with a redshift of 11. Redshift gauges the extending of light on account of the universe's extension, with a higher worth showing more prominent distance. Yet, from the absolute starting point of glass discernment's 2 separate gatherings, including one drove by Rohan Natu, autonomously recognized glass Z13, with a redshift of 13, driving the tremendous timeable back altogether further in their scramble for fast results. Experts relied upon worked-on strategies for redshift appraisal in light of brightness assessments, rather than extra time-concentrated direct assessments. Notwithstanding their ease, these assessments revealed universes unexpectedly splendid and colossal, some previously parading a notable mass rising to 1 billion suns, similar as our own. The energy didn't stop there. In the ensuing days, various universe contenders from diviners and glass emerged, some with redshift measures as high as 20, showing they existed just a brief time frame after the huge explosion. These universes showed circle-like plans not expected in such early cosmic ages. Moreover, another gathering tracked down verification of smooth squander frameworks at a redshift of 10, under 500 million years after the tremendous explosion. Such quick ascent of sizable universes challenges the assumptions for the standard cosmological model, lambda cold dim make a difference. To get a handle on this peculiarity, a brief get back to early universe components is principal in the basic minutes after the colossal explosion. The universe was a hot, thick soup of right-on-time stage particles. Over the long corridor, as the universe broadened and cooled, helium and other light parts framed, provoking the presence of the head particles something like 400,000 years after the truth, roughly 100 million years after the gigantic explosion. Conditions became accommodating for the advancement of the chief stars, made basically out of hydrogen and helium. These early stars, greater and more astonishing than current stars, amassed into proto-universes, coordinated by the gravitational draw of faint matter. Anyway, JWST's disclosure challenges this model, as it uncovers awe-inspiring sizable cosmic frameworks far sooner than expected. Stacy M. from Case Western Hold School saw the surprising deficiency of different more humble protogalactic parts, proposing that some notice frameworks may be nearer than accepted, concealed by dust appearing to be dimmer and more far away. The revelation of the early universes raises critical issues about the universe's beginning phases, featuring the requirement for continued examination and change of our cosmological models. Follow-up insights of glass Z13 in August 2022 by the Atacama Huge Millimeter exhibit in Chile project vulnerability on the hidden revelations. No matter what the use of brightness-based assessments, ALMA didn't perceive basic proportions of buildup related to glass Z13, as P. Tom B. from Goya School, who drove the discernments, said. This recommends that low redshift interlopers can be avoided, but ALMA endeavored to perceive the universe by any means. This highlights the trial of certifying discernments made using JWST's high abilities. Rohan Natu, one of the experts being referred to, raised the incongruity of the situation, communicating, "The inspiring news is there's nothing distinguished." He said, "The horrendous news is there's nothing distinguished to just. JWST is fit for returning again to its own insights. The most incredibly alarming explanation could be that the norm LCDM cosmological model requires refreshing." Michael Bohan Cullen, a cosmologist, conveyed the size of the trouble in connecting calculations with observational information. These high redshift frameworks, showing weighty movement models for star advancement and development that were hard to clarify inside current cosmological hypotheses, could bring about an extraordinary conversation about how things started and, basically, our place in the universe. As cosmologists deal with these new disclosures, the James Webb Telescope's effect on astronomy may provoke a reevaluation of existing standards and thoughts, spurring scientific interest for years to come.